Professor Satish Kumar sir, are you in line? Shall we start the session,
Yes,
sir,
sir.
now?
Good morning, sir.
Okay, good morning, Satish Kumar sir, and good morning to one and all who is present in the meeting as participants. Thank you, one and all. So this session will be started with a brief introduction about our resource person guest lecture for this session. Mr. KRP Satish Kumar, who is working as assistant professor now from the past 10 years in Kumaraguru College of Technology in the Department of Civil Engineering, and he has completed his UG in Civil Engineering at in the College of PAG College of Technology, Coimbatore, a well-known famous college across the nation, coming under Anna University. And after that, he has completed his Master of Engineering in the specialization of structural engineering in College of Engineering, Dindi, Chennai. We know as Anna University. It's called as Anna University, Chennai. So from where he has completed his Master of Engineering in structural engineering. Now he is also doing his PhD program. It's going on in Anna University, Chennai. So he's having an industrial experience and worked as an assistant engineer in Tata Consulting Engineers Limited for some years as a design engineer. And he's having a design experience. He has worked as a design engineer for Kodangulam Nuclear Power Plant Phase 2. He was the design engineer for that project. And also he was worked as a design consultant for Kunda Pumped Storage Hydroelectric Project. So he's having software skills in the areas as ANSYS, StatPro, OpenFOAM, etc. He is having life membership in the Indian Concrete Institute and a member in the Institution of Engineers India. So he has published papers in 3 international conferences and 7 papers in international journals and 12 publications in national journals. So with this brief introduction, I invite Professor Satish Kumar sir to conduct this session to carry out his guest lecture. Thank you, sir. Thank you. I invite. Now I will hand over the session to Mr. Satish Kumar sir. Thank you.
Thank you, sir. Thank you so much for the introduction. I will share my screen now.
Okay, sir, you can share now.
Sir, can you confirm whether the screen is visible? Sir, is my screen visible?
Visible, sir. It is visible.
Okay, sir. Thank you, sir. Thank you so much. Good afternoon to everyone. My name is Satish Kumar. Today I'm here to discuss something about cementless concrete. I hope this is the last session of this particular DP program. So I'm going to discuss about this particular topic in a very broad sense. So the contents for today's presentation are I'm going to give a brief introduction about the concrete, about cement, and the ingredients of cement, what is the role of cement in concrete, and some of the substitutes for cement, and in brief about 2 products. One is the FALG and the other one is the geopolymer. And I will also discuss about the experimental study which was conducted in our institute. I'm not at the liberty to give the numerical values, but I will give the qualitative parameters. I hope most of these are very well known to many persons, but to refresh, I'm going to discuss about these. Concrete is a building material, as we all know, but it is popularly known as an artificial stone. So what we are trying to create is an artificial stone out of some ingredients. And this artificial stone is not made up of one single ingredient. It consists of different materials. So this is equivalent to a composite material. A composite material has a matrix phase and a dispersed phase. So when we are discussing about concrete, the matrix phase is nothing but the cement phase, and the dispersed phase is made up of what we called as inert materials. But as the days passed on, those inert materials were also found to be in a reaction with the cement phase. And the inert materials, what we mostly use are the fine aggregates and coarse aggregates. And why we are using concrete for construction or as a building material is that the most superior material which can be used for construction, we can say it as plastics or polymers. But out of that, metals can also be used like steel. But use of these materials in a very large scale, like infrastructure development, becomes a very costly affair. So we are going for a relatively cheaper material, which is concrete. And we all know that concrete is very good in compressive strength, but it is weak in tension, or it needs more tensile strength. So we go for reinforcing this concrete material with reinforcements like steel and other fibers. And nowadays we are also trying to make the concrete bendable to make it more ductile than brittle, because of the predominant lateral forces. We are going for vertical developments. So when we go for vertical developments, we need a more ductile material than brittle material. But unfortunately, the native concrete is a brittle material. And the significance of cement in concrete is that it is the matrix or the binder phase of concrete. When we speak about cement, cement is made up of calcareous and argillaceous materials. So these are the ingredients. At very high temperatures, they form Bogues compounds, which are known as C3S, C2S, C3A, and C4AF. Tricalcium silicate, dicalcium silicate, tricalcium aluminate, and the tetracalcium aluminoferrate. And these Bogues compounds, when they come in contact with water or when they hydrate, they form CSH gels with some calcium hydroxide left behind. So the main ingredients, which are the oxides of calcium, silicon, and aluminum, at very high temperatures, they form the Bogues compounds, and these in turn produces CSH gel. This CSH gel hardens over a period of time, which gives the strength for the cement or the concrete. But the strength of concrete is not only dependent on the strength of cement, it is also dependent on the strength of aggregates. Like in order to obtain high strength concrete, we are supposed to go for high strength aggregates. We are supposed to increase the density of the concrete. In some way, the density and the strength are related. So this calcium hydroxide is left behind. So over a period of time, this calcium hydroxide is also put into use by addition of other ingredients. Now, speaking about the role of cement, as we keep on saying, the cement is the matrix phase or the binder phase. It binds, but it binds with aggregates or the fillers, whether it is in the form of fine aggregates like sand or M sand, or in the form of coarse aggregates, or in the form of any other inert materials. But this binder is also very important because it is supposed to have strain compatibility with the reinforcements. Because we all know that concrete is weak in tension. So in order to take that tension, we are using reinforcements. So the force has to be transferred to those reinforcements in an effective way. So we need some form of bond between this reinforcement and the concrete. So that is provided by the cement or the binder in our case. But apart from this, also acts like a protective layer because this forms the matrix phase, which contributes to a minimum of 15% to maximum of 30% in the concrete. This covers all the materials. So this forms the protective layer for the concrete. Now, when we are speaking about the cementitious substitutes, in the previous slides, we learned about the importance of cement or the role of cement in order to replace cement with some substitutes. Those substitutes are also supposed to perform the same duty as that of the cement. Like they are supposed to have a binding property with the aggregates as well as with the steel, and they are supposed to form the matrix phase, and they are also supposed to last as long as they are also supposed to have the lifetime of the cement. So some of the substitutes which are commonly used are fly ash, ground granulated blast furnace slag, silica fumes, limestone fines can also be used. The combination of clay and lime. This is one of the classical materials, clay and lime. These are the common substitutes for cement. Apart from these, there are other materials like any pozzolanic material. Pozzolanic in the sense which has both calcareous and argillaceous materials, which are in a reactive form. Any pozzolanic materials can replace a cement in concrete. Similarly, any other polymer can also be used which has a binding property. Some of the materials which we had forgotten as a binding materials in the construction industry are there are many binding materials which we have used in the past, but we have forgotten about all those things, either because of the ease of availability of a cement or workmanship and so on. Like the white of egg, wax, honey, casein, linseed oil, bitumen. Bitumen is still used in flexible pavements, but not in construction, but not in buildings or structures. Egg was used in mortars. Similarly, these wax and honey were also used in mortars. Casein and linseed oils, these have much similar behavior to that of bitumen, but they won't match bitumen in some properties. Like in our institute, we had a project where we were trying to recreate the mortar which was used in I hope you might have heard the term Nagarata. That was a part of the Tamil Nadu where they used honey with egg to form the mortars. So in an overall sense, these cementitious substitutes are supposed to have a binding property as well as they are supposed to have a durability as much as that of the cement. One of the products developed by Dr. N. Bhanumati Das and Dr. N. Kalidas in India was a Falgi. This Falgi material has a huge market in brick segment. In India, there are more than 10,000 Falgi brick units. This data was in 2020. And the main ingredients of this Falgi brick is this FA stands for fly ash, L for lime, and G for gypsum. One of the most interesting characteristics of this combination of material is that here gypsum is not a retarder. Gypsum acts as a retarder in conventional concrete or in conventional cement. Whereas in this combination, gypsum acts as an accelerator. This accelerates the reaction between fly ash and lime here. And contrary to the hydration process of the box compounds in cement, in this Falgi combination, no surplus lime is left behind. And no heat of hydration is also liberated. because this fly ash reacts with lime with the gypsum as an accelerator. So this does not involve any heat of hydration. And this reaction is also pretty fast. It has a very less curing time than the conventional concrete. And the color of these bricks, you can observe from here, it is very much similar to the color of the fly ash. It is very dark in color because we don't have any excess lime here. If there are some excess lime, it leads to many other problems. Like it may lead to crack because of the lime has an expansive property, or it may form patches in simple walls. Now, talking about one of the classical material which was not explored, I will say, is a geopolymer concrete. A geopolymer, I want to explain something about the geopolymers. Because in geopolymers, there is a broad classification, like there are organic carbon-based geopolymers as well as there are inorganic silicon-based geopolymers. Where in construction industry, we are exploring only the sector which involves inorganic silicon-based geopolymers, where we use aluminosilicates with alkaline reagents. And the curing for these geopolymers, this needs some external heat to be supplied. So the curing is mainly by either in the form of a steam curing or hot air curing. Still, ambient temperature curing is also possible, but curing is not possible in the case of a cold atmosphere. This reaction, the reaction of the aluminosilicate with the alkaline reagents to form monomers. These aluminosilicates will react with the alkaline reagents to form monomers, and then from the monomers will condense to form the polymers. And this reaction, the rate of reaction depends on the temperature available or the heat available for the reaction to process. So there is a study comparing these two types of curing also, about steam curing and hot air curing. And still there are some researches about low molar concentrations of these alkaline reagents, whether that is possible or not. But most of the researchers have found that low molar components will not have sufficient reagents for this reaction, for this polymerization to take place. So this low molar component study is on a hold, to say. And from this slide onward, I will try to explain what are the experimental study which we conducted in our institute. We were trying to explore the use of fly ash with GGBS. We used a small percentage, around 10% of the fly ash with the GGBS. And the solutions which we used are sodium hydroxide, potassium or potassium hydroxide, as well as sodium silicate or potassium silicate. We were not going for calcium hydroxide and calcium silicate solutions. That is also possible, but the reaction takes place in a very fast manner and it will leave residues. The intended product won't be acquirable with calcium compounds. And the fine aggregate and coarse aggregate which we used were of the normal standards, and we were trying with different molarity, like either in the form of potassium hydroxide or sodium hydroxide, as well as in the form of potassium silicate and sodium silicates. We were doing experiments with 6 molar solutions until 14 molar solutions. We obtained this potassium hydroxide in the form of pellets and this silicates in the form of in a powder form. And this reaction is exothermic. It liberated some heat. But when we compare sodium hydroxide solutions with the potassium hydroxide solutions, the potassium hydroxide solution is highly corrosive in nature. So we were supposed to take some precaution measures when we are using this potassium solutions. And this GGBS was actually crushed, and only the fine particles which are passing 90 microns were used in this particular study. And the fly ash which we used was class F fly ash. You are not able to get an access of class C fly ash, so we are using class F fly ash, which conforms to ASTM C618. And this fly ash mainly contains silicates. We were trying to find the relation between this molarity and the strength throughout the study. And the composition of a GGBS was also found using chemical test for oxides. Like you can see here, all these are oxides. So we found that the GGBS contains maximum of calcium oxide and an equal concentration of silicon dioxide and iron oxide. But there are also traces of sulfur and phosphorus and some form of metallic ion, which is not significant. So the experimental study which we were able to complete are the cube compressive strength, split tensile strength, flexural strength of prism, as well as we were able to test some specimens of beams. The cube compressive strength was done for all the 4 combinations of the alkaline solutions. Like we were trying with sodium hydroxide with sodium silicate, as well as sodium hydroxide with potassium silicate, and then we tried with solutions of potassium hydroxide with sodium silicate and potassium hydroxide with potassium silicate. All the 4 combinations with the different molarities of the solutions, from 6 molar solution until 14 molar solution. And in all these studies, we observed that for the cube compressive, here I will also explain about the method which we used to arrive the composition. We used Harjito and Rangan's recommendation, which was given in 2005. From the density of the concrete, we arrived at the volume of aggregate. From the volume of aggregates, we got the volume of the rest of the components. And the ratio between the hydroxide solution and the silicate solution, we kept that as 1.5. And to say it as in the form of a mixed ratio, the ratio between fly ash, alkaline solution, fine aggregate, and coarse aggregate, which we used, is 1:0.45 to 1.75 to 4. Yes, we were using a large volume of coarse aggregate in our study. We were actually trying to achieve M20 concrete, or we were trying to achieve a cube compressive strength of 20 megapascals. The low molar solutions, namely 6 and 8 molar solutions, they don't have they don't resulted in a very good compressive strength. Like the values are not up anywhere near to 20 megapascals. But what we observed is that the solutions which are having relatively higher molarity, from 10 molar, 12 molar, or 14 molar, all these solutions, all these mixes, they had a very good compressive strength, which is a little more than 20 megapascals. To talk about the split tensile strength of the concrete, the split tensile strength of this geopolymer concrete, it was nowhere near to that of the conventional concrete. It was slightly less than that of the conventional concretes. Similarly, the same result was observed for the flexural strength for prism specimens. The tensile flexural strength of the prism specimens were found to be still less than that of the conventional concrete. This was the arrangement which we used to cure the specimens. Like what you can see here at the top is actually a room heater, because we don't have a facility to cure beam specimens. In our institute, we have a hot air oven, but the capacity of the hot air oven is not sufficient to cure beam specimens. So what we did is we used a thermal enclosure, and within this thermal enclosure we had room heaters, and these room heaters were further controlled by using voltage stabilizers and voltage regulators. In that way, we were able to control the ambient temperature within this enclosure. We were able to maintain temperatures of around 60 degree up to 80 degrees Celsius for 24 hours. We also had steam curing. For steam curing also, we were using a closed enclosure, but the facility is much larger than this. So we were directly using steam curing machines for. And this is the experimental setup which we used for the flexure test on prisms. This is actually a universal testing machine in which we used the arrangement for flexure test on prisms. And for the beams, used a loading frame with hydraulic jack, and we applied 2-point loads. We were expecting a pure flexural failure, but what we arrived is a combination of the shear flexure failure, and the shear failure is observed to be predominant here. The reinforcements which we use for this beam are used 2 numbers of 10 dia bars, both at top and the bottom, and the shear reinforcements is actually 6 mm rods at 100 mm center to center. And the shear capacity and the moment capacity of the beams are found to be much closer to each other from the analysis. And experimentally also we got the same results. And the reason for this kind of a failure, it can be related to the very low tensile strength capacity of this beam, of this particular material. I've already said, even for the high molar solutions, the tensile strength of the geopolymers was much less than that of the conventional concrete. And the dimensions of these specimens casted are this beam is 1.5 meters in length. It had a cross section of 100 mm by 175 mm. And the grade of steel used was Fe415. And with respect to the durability test, we were actually planning to do the durability test, but due to this lockdown, we were not able to continue with this. And this behavior of beam, we were able to record the behavior of beam until the failure. And we observed that for high molar mixes, the beam actually exhibited ductility. In the sense, we observed more deflection before failure. Even though there is not a significant increase in the strength, like the cube compressive strength and the split tensile strength of the high molar solutions in this study, we can say like a 10 molar solution, 12 molar solution, 14 molar solution, those had a very close range. Even though the strength characteristics are much closer to each other, the deflection behavior was found a little different. And some of the inferences from this study are um, the low molar mix. They showed less workability. Like for the slump test, we were able to get only 5 slump for the first two low molar mixes, namely the 6 molar solutions and 8 molar solutions. Whereas the workability was relatively high. We were able to get around 20 slump for the other mixes. The slump value is also very low because we used more amount of coarse aggregates. I do not given the mix here. As I said, we are using the mix is like we can say the fly ash to fine aggregate to coarse aggregate is 1:1.75:4. So the very high value of the coarse aggregates might be the reason for the low slump values. And as I said, we have observed a threshold in the or an upper limit in the case of the compressive strength with respect to the molarity. We were able to achieve good results for the compressive strengths only at high molar solutions, in the sense for 10, 12, and 14 molar solutions. But the result was nowhere near for the low molar solutions like 6 molar and 8 molar solutions. And as I have mentioned earlier, the tensile strength of the geopolymer concrete is found to be much less than that of the conventional concrete. We were trying to attain 20 megapascal as the compressive strength, but the split tensile strength was only around 1.8 megapascals. And the comparison with respect to the nature of curing. In the previous slide, I have shown a method for hot air curing. This is an in-house setup for hot air curing, but this method of curing showed that it actually evaporates structural water from the elements. Whereas in the case of steam curing, we were able to achieve very good results. To compare the results, in this particular hot air curing method of curing, we were able to get around 20% less than the results than that of the steam curing. And with respect to the high molar mix, these mix exhibited more deflection in the case of beams. So from this, we are trying to get the ductility of the material, because high molar solution, in the sense only the alkaline component is changing. We are not actually changing the fly ash ingredient. Only by increasing the alkaline reactors, the behavior of the material is found to be towards ductility rather than brittle material. These are some of my references. And thank you. It's time for some discussions. Participants?
Sadish, are you continue or it's time for discussion?
Sir, time for
Are you able to hear, sir? Sadish Kumar, sir? Hello,
yes,
sir.
It's time for discussion.
Yeah.
So I would like to discuss more.
Okay. Oh, it's time for discussion now. Okay. Participants, if you're having any queries and discussions regarding concrete tech for this topic or any concrete technology, you're having any clarifications, you can ask Professor Sadish Kumar, sir.
Very good afternoon, sir.
Yes, sir. Good afternoon, sir.
Sir, there is one query from my side that whenever we are preparing the mix for the geopolymer concrete, over there, which IS code we would prefer to prepare the mix, and when we are comparing the samples which we get after the compressive test, we need to compare with some conventional concrete or with some nominal mix. So, which mix which we are comparing it? So, which mix it should be? Like you said that you were getting the strength near 220 pascals, megapascals.
Yes, sir.
So, how was the ingredients were prepared so that we could achieve that strength?
Yes, sir. Geopolymer concrete is not actually a new material. It is in existence for around 4 to 5 decades. Um, but the thing is that we don't have stipulated recommendations to say. Like the IS code does not give any fixed recommendations because there are different ways in which we can prepare this polymer material. This polymerization process it can be done in an n number of ways. And like I said, from the studies, we can also observe that the strength it varies on a very large number of parameters. Like even the temperature at the curing, that will also have an impact on the strength of the concrete. And similarly, the nature of the alkaline materials, about the nature of the fly ash. There are many guidelines given in literatures where we can refer to.
Okay, sir. Okay. Thank you, sir. Thank you.
We can also go on to try with the organic polymers. Like, until now, we are only using inorganic polymers for geopolymer concretes, where the main where we are highly dependent on silicon oxides.
Right, sir. Right. And did you face, sir, any problem during the time of curing, because you were like in ovens, when we put it into the ovens and we put it up to a temperature of 60 degrees Celsius, and over there curing can be done due to that heat from all around for a particular sample. But when we create, like you created atmosphere where the curing was done putting by those heaters.
Yes, correct, sir. Since we were using an in-house arrangement for curing the specimens, actually the temperature of the specimen was different on the phases. So for that, we have to keep on rotating the specimen so that it gets an averaged temperature over a 24 hours time.
Okay.
And that itself was actually hindering the process of curing. And what we didn't expect is that there was a loss of heavy loss of water from the specimens when we were using that hot air curing.
Got it, sir. Got it. Thank you, sir. Thank you.
Thank you, sir.
Participants, any
Like I'm ready to interact on anything about composite materials and about geopolymer concrete. Um, we were also discussing about the case of egg and honey, which was used for concrete. We can also discuss about those things. Okay, if someone is interested, I can also discuss about the other project in which we were using egg and honey for the preparation of a binder material. Anyone, can you just raise your hands to show that you are still present and we can continue with that?
Sir, when you add egg and honey, what property will be changed, and can you give an explanation on that?
Yes, sir. Actually, this um, the property in the sense you are trying to ask about the chemical properties or
Yeah, both chemical properties as well as the fresh properties of the cement or the when it is added to with the water, and what is the benefit we are going to get when we add then? And
yes, sir. We are actually getting a binding material. That was what we were able to achieve. And this binding material is also was also organic in nature. There is some process involved for the preparation for this also, and that particular process makes these materials as a binding material. If you want, I can also explain with those process in detail.
what are the materials you're going to add along with this egg and honey, which makes no these materials as a binders? That was my question. And how it will act as a binder?
Yes. Show on slide.
So my voice is audible?
Yes, yes, your voice is audible. I'm trying to get a
Okay, okay,
picture for that particular.
okay, okay, sir, fine.
This process is very common in Karaikudi, where we call the houses as Chettinad houses, and they were using honey with a seed of a plant name by the name Kadkai, with lime. The lime was also in the form of hydraulic lime. And the initial process was they used to prepare lime first, and lime was prepared from the shells, and this lime was prepared with fine sand as well as with marble dust, and this was used as the main ingredient for the mortar. The calcium carbonate, which is present in the shell lime, when heated, they will give rise to calcium oxide and calcium dioxide. And this calcium dioxide is liberated as a gas, and at last we will have only calcium oxide. This calcium oxide reacts or hydrates in order to give calcium hydroxide. And this calcium hydroxide again reacts with the liberated carbon dioxide, and it forms calcium carbonates. And these calcium carbonates are the main reason for the binding property here. And with respect to the jaggery, jaggery is composed of the forms of, not jaggery, honey. Honey, it contains the forms of sugar in the form of glucose, fructose, proteins, and minerals. But we are not concerned about proteins and minerals. But the forms of sugar, that is actually soluble in lime. This helps in the conversion of calcium oxides to calcium hydroxides. So that is the main role of honey in this process. And the process of the preparation of lime from the shells, that itself takes around 30 days.
Okay, thank you, sir. Thank you. I got it.
Like after the preparation of lime and then mixing it with honey, what we can observe is that it will liberate carbon dioxide, and the carbon dioxide will dissolve within itself. And at the last, we will have something like in the form of white paste. I'm sorry, I'm not able to show the pictures here. But that lime will form something like a white paste kind of thing, which we can consider it as an equivalent to cement paste. And the can anyone say about the role of these calcareous materials. Calcareous materials, these are involved in all these three ingredients. But what we need is only this calcium silicate gel. So actually the chemical process which is involved in a cement is much more complicated form. That is actually reduced in the other forms, in the other binding materials. Like in the case of this fly ash, lime, and the gypsum, we are using only two ingredients, namely the fly ash and the lime. We all might know that these components are responsible for the initial setting time, final setting time, and so on. One is responsible for quick setting, but all these can be simplified in a very simple way from the classical methods.
Can we replace fly ash from cement concrete instead of cement?
Yes, sir. That is also possible, sir. Like in geopolymers, we are actually replacing the binding material. Like the matrix phase alone is changed, whereas the dispersed phase remains the same. Like we are using the same fine aggregate and coarse aggregates, but the only thing we are replacing is the matrix phase, which is from the cement. We all know the difference between the ordinary Portland cement and PPC, where we use high volumes of class C fly ash. Even after adding a huge volume of fly ash, we are still replacing cement with some volumes of class F fly ash.
So, in manufacturing fly ash quality bricks, somebody is using cement, somebody is using calcium. What is the difference between these two, and what are the advantages by comparing these two? Can you explain, sir?
Can I come again, sir? I'm not able to get your question. Sir, can you repeat your question?
See, while manufacturing fly ash bricks, somebody is using lime instead of cement. Somebody is using only cement. Can you differentiate these two in way of chemical reaction and also strength?
Sir, like the fly ash bricks as mentioned in this Falgi bricks. Here we are using only fly ash with lime, where no cement is involved. If cement is involved, then the chemical reaction itself is different. Like in fly ash we have silicates, and in lime we have calcium. These two will react to form the calcium silicate components. Whereas in cement we have the Bogues compounds, and a separate reaction will keep on going. And the excess lime from the hydration of the cement, that will also be consumed in this reaction also. But what happens when we combine this fly ash, lime, gypsum with cement is that gypsum acts as an accelerator for one component, whereas it acts like a retarder for the other component. But the ultimate product is only going to be the calcium silicate component. Like if you are using these two things together, it's like using two compatible binders in a single matrix, which will give the same ultimate product.
In 3D printing, will they use cement or exclusively some other material in 3D printing technology?
Yes, sir. In 3D printing technology, we are supposed to get quick setting as well as um, the print head must be sufficient to handle the material. Like we cannot go for huge amounts of coarse aggregate like what I have shown in my study. We can go for only the fine aggregates and the we should have a controlled flow also. Like if the concrete is uh, uh, if the concrete is more viscous, if the solution is more viscous, then that also plays a problem for the print heads. This combination of the fly ash, lime, and gypsum is more suitable for 3D printing rather than the conventional concrete. Like, even though we use some additional like accelerators for cement, that is also possible, but the most preferred is this fly ash and lime combination. With the variation of the various grades of a fly ash, also sometimes they need compressive force. We need to apply some initial pressure as well as temperature for curing for some forms of the combination of these materials. Like fly ash, when we include the alkaline reactors, in such cases they will need additional temperature. So closed enclosure for maintaining the temperature is required for curing. Whereas this combination of fly ash, lime, and gypsum, where gypsum here acts like an accelerator alone. It is like a third component which facilitates the reaction. Instead of gypsum, if we are using the alkaline reactors, then the nature of curing and the time involved for setting of the concrete, all those things varies. So the commercial units which say that they are producing fly ash, there are different types of producing fly ash bricks.
Thank you, sir.
Okay, participants, are you having any queries? You can continue, or otherwise we can close the session now. Okay. Thank you, Professor. Thank you, Professor Satish Kumar, sir, for your valuable lecture on cementless concrete. In this session, this is the last session of this FDP program, national level program. So in this area, he has covered, the professor has covered a topic on cementless concrete. And in this main topic, he has covered subtopics like what is the fundamental of concrete, fundamental ingredients of concrete, and nature of concrete and its ingredients, and what is the role of cement in concrete, and what are the ingredients of cements, and what are the substituents for the cement instead of cement, what are the other binding materials that can be used for getting a good concrete, that he has discussed so far. And also he has discussed about fall bricks. It is latest building material instead of earthen bricks. Nowadays it is widely used in construction activities because of scarcity of availability of earthen. That means source is limited. Earth source is limited, and good soil is availability is very limited. So especially in Tamil Nadu, it's totally this construction industry moved towards Falji bricks. So here we are having a lot of thermal power plants in Tamil Nadu and throughout the nation also. So many like huge quantities of fly ash is coming out of the thermal power plants, and it is used in cement industries and also for manufacturing of Falji bricks. He explained nicely about Falji bricks, and also the importance of geopolymers in current scenario, how it having a very important role in manufacturing of concrete without cement. And also he has presented his experimental study on fly ash concrete, what he has done as a project work. So thank you, Professor, and thanks to the participants for patient listening and cooperation and nice interaction with Professor sir. Thank you. Thank you. Thank you, Professor Satish Kumar sir. Thank you.
Thank you, sir. I would like to thank Dr. Tanvel sir, Principal of Shakti Polytechnic College, Dr. Shanmugam sir, HOD of Civil Engineering Department, Dr. Nagarajan sir, organizers of this Atal FTP, as well as my head of the department, Dr. Salvan sir, and my alma mater, Kumbaraguru College of Technology. The sponsors of the event, AICTE Training and Learning Academy. Thank you, everyone. Thank you for patient listening.
Okay, thank you, sir. Thank you. Thank you. Now, dear participants, the session will be opened at 2:15 p.m. So in that session, 2:15 p.m. So a question bank, multiple choice question paper will be given to you. Will be shared in the link. As it containing so 20 number of multiple choice questions on the concrete technology. So you have to answer the questions, and you have to score more than 60% in the examination for getting certificates. So it is mandatory one guidelines given in the Atal program. So we will meet at 2:15 p.m. So for 1 hour, the question answer for your examination session will be go for 1 hour. After 3:15, the validity session will be started, and it may go around 40 minutes. So, and also it is very important one announcement that you have to give feedback. So some one of the person, Kirti Gowda, the name is Kirti Gowda, Mr. Professor sir, has given his name for giving feedback, and we need some more persons. So at least 5 number of participants are requested to give feedback about the FTP that we have conducted in this week. And okay, so if you give your name in the WhatsApp group, so one by one it is possible to call you to giving your feedback. So you are requested to give your names and post it in our WhatsApp group, sir. Thank you. So if anything, any doubts or any queries, you can ask regarding the program, and we'll close the program now. We'll start exactly at 2:15 p.m. as an examination session. Anything, sir? Okay. Okay, the session is closed now. I will meet at 2:15. Thank you. Thank you, sir. Thank you.